Hello, my name is Manoj Prakash, and welcome to the series of Windows-based attack and defense. And this is the first part of the series, and we'll be focusing on Kerberoasting. We're gonna simulate this attack, and we're gonna detect it using sim tools. Now, starting with, let's start what is Kerberoasting. Let's see before simulating whole scenarios and how it works and things like that. Let's get some basic using this particular diagram. Now, Kerberoasting is a technique used in Active Directory environment that abuse the Kerberos authentication protocol to extract and crack service account credentials. The interesting part here, it does not exploit a bug, but it exploits a design and assumption about the password. To understand the Kerberoasting, we have to understand about service principal name. Now, service principal name is simply a unique string that maps a network service like SQL or HTTP to the domain account that run that service. For example, here if we have a service account, we have a user or computer and the domain and the port number. Now, this SQL server is backed by the service account. It tells the Active Directory this SQL server is backed by the service account. Now here is where the attack surface comes from. Now allies, we have to know one more thing. It is a post exploitation and it's not an initial exploitation. We have to compromise some domain joint user account. Now here allies can enumerate anyone service account. I mean service account SPN. So this how the actual scenario comes from. Allies can enumerate SPNs, that means they list which service are backed by the domain, and Ally is gonna request the Kerberos ticket granting service ticket for those SPN. Now before going to that, why we need SPN? SPN is basically a unique identifier. Let's say we have a domain and it have n number of service account. To easily identify each service account, we assign SPN to it. Now Ally is gonna make a ticket granting ticket request, that is request which contain the username, the SPN of the service that allies wanted to access, and it gonna encrypted, and it do have a timestamp and other options. It encrypted with the password of the allies. Now this thing is sent to the KDC in the domain controller. KDC is Kerberos distribution center, which is responsible for decrypting this request, ticket granting ticket request, and verify it, and gonna send back a response. And this response is basically AS response. Now it do have TGT, the ticket granting ticket. Now with this ticket granting ticket, the user actually request for the ticket granting service. Now its whole authentication process of the Kerberos. Now with this thing we have ticket granting service. Now ticket granting service is, it's simply a ticket that can be used to send to the service account to access and use that particular service. But our focus here in the Kerberoasting is basically the domain controller return the ticket encrypted with the service account password hash. So this is basically encrypted with the service account password hash. So if we can decrypt, that is by using tools like Hashcat or John D repair, we can actually do the brute force attack to crack the password of the crack the ticket if it have weak credentials or weak encryption algorithm like our C4 or DES. We can actually crack it and see the plain text password. So what make this powerful is that cracking happens offline. So there is no account lockout, no sim alert about brute forcing, and no noise back to the domain controller. And in many environments, service account have weak passwords and they never rotate the password and often run with a escalate privilege. So that means a single recovered service account password often lead to lateral movement and privilege escalation. Now let's see more about this. Let's dive into doing this actually in a real environment and see how it works. All right, let's start the whole scenario. Now we're gonna make an attack. Before that, I'm gonna start my voice so I can show you how it happens. Let me give a glimpse about what we're gonna do. though this is my attacking machine. We gonna find we already compromised a valid user, AD user, who doesn't have any split privilege. Now we're gonna enumerate the SPN. That means they is gonna list which service are backed by the domain account. Then we're gonna request a TCS ticket, that is ticket granting service ticket for those SPN, and the domain controller gonna return the ticket encrypted with a service account password and hash. Then we will be not covering about cracking the password in the offline, but I'll show you the what are the different type of encryption that been used while requesting a ticket, and we're going to discuss about that in a bit more. Now I'm starting my Wazuh right now. Before configuring all these things, let me show you. We're going to use a particular tool called, or a script called get user SPN, and I know my DC IP address is 192.168.177.10, followed by the domain name, and that is .sec.local, and the user we compromised. We do have a valid compromised user. Suppose exploitation, as we discussed before. Okay, okay, I'm gonna enter my right password right now. So if you look into this, we are actually enumerating the SPN. So we already seen what is SPN and why it's important. Let me give a better idea. So in simple, SPN is a unique service identifier. So yeah, it used for authentication to associate a service instance, the service lockdown account. If you see this whole unique string, you could see the user owned the service account and the actual service account name, followed by the domain and the port it is posted on, and the name is basically SQL service, which I'll show you and compare with the Windows domain controller user computer, active directory users and computer. We will be seeing that now. If you go to tools and move to the active directory users and computer, you have to enable the advanced detail, by the way. Now if you go here, you could see the same user service account which associated with a SPN, that is service principal name. Now uh, yep, okay, let me go and show you the attribute. If you search for service principal name, you could see this principal name which we have enumerated in our attacking machine. So it's basically when Kerberos ticket granting service ticket is asked for, it gets encrypted with the service account NTML password has. So it's the important step. It's one of the enumeration step we should focus on. So once it's done, we gonna I also wanted you to show the user account we compromise. This is the user account we compromise. We know his password. That's why we are able to enumerate the SPN. Now I'm gonna request a ticket for the service account we enumerated, which have associated service principal name. Now at background my Wazuh is running. I just wanted you to let you know about that. I'm gonna enter my right password right now, and it's gonna get me ticket granting service, and we're gonna got whole hash. Now the thing we have to see here is there is a significant difference in the cranking speed of this AES, DES and RC4. So while the security best practice recommending disabling RC4 and DES, many environments do not because it does not support. I'll go to the Kerberos and show you the whole authentication process. We have authentication request, authentication response, which we have discussed before. As I said, we do have many options, many field, but the field we are currently focusing on is E type, is basically encryption type. If you go here, you could see the value as a 23, basically RC4, which has MAC. I'll give you the list of all the encryption type and their ETSA value in a coming clips. Then once we get authenticated, we can once we get authenticated, we'll be getting a ticket granting ticket. Using that, we can request for ticket granting service. Now once we requested, and the NTLM password as of the service account is will be a part of ticket granting service, which will be sent as a response, as a ticket granting service response. So same, we'll be focusing on what type of encryption is being used. It's major indicator for detecting this kind of attack, because if you look into the actual actual Windows event ID, that is 4769, is gonna be generate huge amount of that volume. So it is impossible just to filter that attack with just that parameter. So we do need other parameter like encryption type. So if it is a RC4 or DES, we could assume that it's a possible attack. Now when I talk about the encryption type, by default the ticket is created by KDC will be one of the most robust or highest encryption available on the supported. However, attacker can force and downgrade back to the RC4. I'll show you the event. I'll show you now. I am using Wazuh. I'll show you the event. Right now we have requested the ticket as a malicious actor. Now you could see the possible Kerberoasting attack is logged. Due to my rule is fired right now. There is two parameter I have used. The service account, you could see the field there, and two parameter is ticket options and ticket encryption. The 0s17 is a HSA value for RC4 HMAC. Now I'll show you the raw logs. Now this raw logs contain the event ID 4769 followed by the ticket option and ticket encryption, which are the three field we are focusing. But one of the main field is these two fields, because it's one of the major indicator that there is a possible of Kerberoasting attack happening on our environment. It can reduce the amount of false positive, where we could focus on the actual attack, because most of the attack will be happening on downgraded or C4 or DES algorithm, which is by default it's disabled but in legacy system. So let me show you the rule. If you go there and see the manage rules and local rules, we can go to custom rules to find the local rules. Yep, this is the rules I have created. We have mentioned the 4769 event, which is a ticket granting service request, and we mentioned the option, which is option that usually comes to the picture when we are using script like get user SPN .py. Now we do have the encryption type. So I have mentioned a simple description to log it. You can also mention the MITRE ID and so on to make it even complete, which we'll be seeing in the coming videos. I just want to conclude, this is how we gonna detect it.